Welcome back, friends. Welcome to session 8, OpenStack Networking with Neutron. My name is Ram. Agenda of the session is architecture and components of Neutron, manage network resources, manage project security group rules, manage quotas and verify operations of network services. Architecture and components of Neutron. OpenStack Networking is one of the most complicated OpenStack service. Look at the concept here. We have router and the service is provided by Neutron. It helps you in creating virtual routers. We have different networks like tenant network 1 where we have virtual interfaces. So again, these services are provided by Neutron. Instance 1, instance 2, multiple instances are there, and you can configure virtual network for these instances, and then we can create the entire network to connect to these virtual instances. So we need a virtual port also for that. So we are going to create virtual interfaces, we are going to create networks and virtual ports. Same way, this is another network, tenant network 2, right, demo net 2, virtual interfaces, and this is how they are working. This is a compute node where we are working on this, right. This is the architecture, brief architecture of components of Neutron. What are the different components? We'll understand one by one of all of them. Network, tenant network, a virtual network that provide connectivity between entities. That network consists of subnets, and each subnet is a logical subdivision of an IP network. A subnet can be public or private. Virtual machines can get access to an external world through the public subnet. That means if you want to give access to your virtual machine to the outside world, you need to configure public subnet for that. If a virtual machine is connected only to the private subnet, then only other virtual machine from the same particular network can access it. This will be a typical requirement when you will configure your own cluster within the cloud, wherein you want the nodes to be internally connected but not to the outside world. Only a user with admin role can create public network. Components of OpenStack networking. Router. Router is a virtual network device that passes network traffic between different networks. A router can have one gateway and many connected subnets. Security group is a set of ingress and egress, that is incoming and outgoing firewall rules that can be applied to one or many virtual machines. It is possible to change the security group at runtime. If you have a cluster and you don't know which machine will be up at any point in time, and you have services running on multiple machines, then you need a constant or fixed IP address which will change from one machine to another in case one machine goes down. So that IP address is called floating IP address. So it is an IP address that can be associated with the virtual machine so that the instance has the same IP from public network each time it boots. Ports. A virtual network port within OpenStack networking. It is connected between the subnet and VNIC or the virtual router. So when we are going to create subnet, we need to connect it to the router through the port. So port gives you the connectivity to connect the subnet with the router. VNIC or virtual network interface card. It is an interface that is plugged into port in a network. Look at the components we have to configure. We have to configure subnet, we have to configure a router, we have to configure a port to connect that to the router, and obviously we need a virtual private network interface card also, VNIC. Documentation from docs.openstack.org defines several types of OpenStack nodes. Neutron is usually spread across 3 of them. API service usually exists on the control node, and Open vSwitch and client-side Neutron agents are usually started at the hypervisor or the compute node. And all server-side components of the OpenStack networking service work on the network nodes, which can be a gateway to an external network. Neutron architecture, complete architecture of Neutron. So we have Neutron service running on the control node and network plugins. To store the details about the connections, networks, metadata about the networks and subnets, we have database. And to connect to this entire Neutron, we have Neutron API. Then underlying connections through the DHCP agent or L3 agent or metadata agent or Open vSwitch agent, Neutron from control node communicate through RabbitMQ. And on the compute node, we have Neutron Open vSwitch agent, that is OVS DB server and OVS SV switch D, that is switch D. On network node, we have these things. In our case, we have a control node and compute node. We don't have a separate network node. So network node related services in our case are running on the control node itself in the demonstration which I am going to show you right now. All these agents are up and running, and I have demonstrated how to configure and how to install these components in my lab assignment. The daemons, let's take a look at the daemons first running on the system. So this is my controller. On the controller, what I have is Neutron DHCP agent service, Neutron L3 agent service, Neutron Linux Bridge agent service, all are running. You can see that. Neutron Linux Bridge cleanup service, Neutron metadata agent service, Neutron server service. These are running on my controller. And on my compute, we have 2 services running. One is Neutron Linux Bridge agent and second is Linux Bridge cleanup service. These are running on my compute node. This is my setup. Okay. So with this setup, let's understand these components. Neutron server, the main service of Neutron. It accepts the routes and API request through message bus to the OpenStack networking plugin for action. Neutron OpenSwitch agent, it receives command from Neutron server and sends them to Open vSwitch OVS for execution. Then we have Neutron OpenSwitch agent. It uses the local Linux command for OVS management. Neutron L3 agent, this agent provides routing and network address translation using standard Linux technology like Linux routing and network namespace. We have Neutron DHCP agent. It manages DNS mask service. It's a lightweight dynamic host configuration protocol DHCP server and caching DNS server. Also, Neutron DHCP agent starts proxies for the metadata server. Neutron metadata agent, it provides the ability for the instance to get information such as hostname, SSH keys, etc. Because virtual machines may request these informations at boot time. Usually this happens with a script like Cloud Init. An agent acts as a proxy to NOAA API for retrieving the metadata. The services and their placement. Neutron service run on control node and the file name is neutron.conf. Neutron OpenSwitch agent, it run on network on compute node. The file name is plugin ml2 OpenSwitch agent.ini. Neutron L3 typically run on network node and the file name is l3 underscore agent.ini. DHCP agent, DHCP underscore agent metadata agent, metadata underscore agent dot ini, and modular layer 2. It's not run as a daemon. The file name is ml2 underscore conf dot ini. Alright, so typically these services run on a separate network node, but in our case we have spread them across two nodes only. One is compute and one is controller. Here's the example configuration of code from the configuration file of for Neutron Open Switch agent. Let's take a look at this. We can give this command directly. Grab, as I've been explaining in throughout my previous sessions, you can simply use this regular expression for fetching the metadata, right? So this is to fetch the data about this agent. Let's look at this, because we have the agent service running on this L3 agent, right? We have L3 agent service running on this, and DHCP also is running. So it will give you the details. So there is no specific configuration on this right now. So no configuration, default configuration setup for this is done on our system. Manage network resources. Same way you can check the other networks also, by the way. Let's create all necessary network resources for connecting an instance to the external world. Let's in the meanwhile start the browser also, so that we can take a look at the browser specific settings also, and we can work on the network. So here we are on our dashboard, Horizon dashboard. Once it starts, we'll see existing network and we'll delete all of them if they are, and we'll create them from scratch. Okay, so let's create all necessary network resources for connecting to instance to the external world. For that you will need Neutron command, and you can also use Nova command. Both commands have built-in help, like Nova help or Neutron help subcommand for getting help on a particular command. So first thing is, obviously we need to get the environment variable set, and that we can do using the source admin-openrc, as I've been discussing in every session, that yes, first thing is you need to set the environment variables. So source, this is on compute node, we have to work on the controller node. So let's start on controller. We are working on controller now. Source admin-openrc. What is there in this file? You can take a look at once again. Admin-openrc. So this have the project domain name, user domain name, project ID, username, password, region name, auth URL, interface, identity API version, image API version, volume API version. All these details are set in this. Now if you see Nova list, and we'll see the network also, and to configure to create a new network, we're going to use this command. And here our dashboard is up now, and you can see on the network, go to compute, and here the networks. So click on networks, you will see the networks, available networks, and we have ext network already there. Alright, when we go to this ext network, I'm going to delete this, and I'm going to delete the ports also, because I'll be creating this from scratch once again. Okay, I'm deleting the ports, and then subnet, because you cannot directly delete the subnet. So ports are deleted. Now you can delete the subnet. Remember, to delete all this, you need to first delete the floating IP if there is any associated floating IP address. Once the floating IP address is deleted, you can delete the ports. You will not be able to delete the ports unless you delete the floating IP. Then you delete the ports, and then the subnet. And now you can delete the subnet also, because now there is no associated subnet or floating IP with this and ports associated with this. Now you can delete this, because I'm going to create the same again. Okay, now there is no more network available, so now we can issue the same command again, Neutron net create ext network. Okay, First, what am I trying to do is I'm going to use a flat. Okay, and I'll show you if the flat is not working where the setting is to be done. I must tell you that it may not work, it may fail, but VXLAN will be created. That is true. Because if I use flat, I can use, let me create one more network. So the network is created, you can see the details. Alright, availability zone, everything is set up. This is not default, and name is extnet, right? So VXLAN type. If I use to create another network, VXNet1, but of type flat, let me try this flat also, which I know if I have not configured something it will fail. So I will tell you that region also if it fails. Alright, and what setting is required. Look at this, it is failed because one setting is required for this purpose. Let me explain that also, and we'll try to create this again. So the network ext net is created. If you can't create a network with type flat, then add flat to the type drivers in etc neutron plugin ml2 underscore conf.ini file. After that, you will need to restart network neutron services, and then you will be able to create the flat type also. Right, next step is to create the subnet in this. It will be an external existing network, and you will need to disable DHCP for this network. So this is how subnet is created. Neutron subnet create extnet, because this is the network which we have under which we want to create. The name ext subnet, allocation pool starting and ending, disable DHCP gateway. So let's create this subnet also. Neutron subnet create. Okay, to save time I'm using this, there is no other region. So Neutron subnet create extnet, the name is ext subnet. Okay, then allocation pool, the IP address, range of IP addresses to this pool which will be available for allocation. And then gateway, DHCP is not to be allowed, so we are disabling the DHCP for this. Alright, and then it will be created. So we will have subnet. Now it is created. DHCP we have disabled. Default gateway is 10.0.2.2, right? So subnet is also created. Fine. So we have created network, we have created subnet. If you are using Horizon, you can go and project network and create network from the Horizon also. Let's take a look at that also, how to create it from there. Now if you see, you can see that from here we have ext network and we have ext subnet also, right? So we can create from here also network, create network, and you can give the network name, let's say extnet1. Alright, so this is second network I'm trying to create, is going to be shared, and create a subnet for this. If you are enabling create subnet, then you can use subnet on this. I'm not going to want to share it. Availability zones, this Nova and subnet, you can specify the IP address range. It should not conflict with the existing one. So let's create 10.0. Okay, subnet ext subnet 1, because that subnet is already created. Network address 10.0.1.100. That was network address is 10.0, sorry, 1.0 and /24, and gateway IP address is 10.0.1.2. let's create this IP address. Subnet details, you want to disable DHCP, you can enable this. If you want to enable DHCP, you can enable it. Let's try to enable the DHCP. Alright, allocation pools, what is that? IP address allocation pools. Each entry is start IP address and IP address. For example, 192.168.1.100 comma 192.168, right? Only one entry per line. So let's add this 10.0.1.200 comma 10.0.1.220. we want to allocate only 20 IP addresses. Alright, DNS name servers, host routes, we are not configuring any other thing. So if everything is set, if there is no syntax error and there is no problem, it will create that subnet with along with the subnet also. So fantastic, it is done. So ext net1 is also created and it is up and running, and this is how it is, right? So you can go to edit network, you can edit that also through this. So you can specify this details here. You click on this, you'll get the details like this, right? Subnet and the ports. Right now we have not configured any ports, right? We can configure the ports also. This is the default port, fixed IP address. So this is the default one, right? Let's go to the now next topic. This way you can create using Horizon. Verify the netlist, Neutron netlist. Let's look at this with the command line. Neutron netlist, right? This will give the network list, Neutron netlist. And if you want to see a particular, then you can use Neutron show, right? Neutron net show, and with the IP address. For example, we just created this one, so you can give the IP or the ID of the network and show you the details of that subnet. So this is the command line way of creating and displaying the information about the network. Same way I have already demonstrated this on the through the Horizon dashboard. Create a network. Now the rest of the work you can do as a demo user also from the demo project. Actually only one action where you need an admin role is when you name the network as external. For internal you don't need this. Let's create a tenant network, that's for the demo network. So for this you don't need admin OpenRC, you need a demo script. If you have used that, you can use that also, right? So if you have followed my previous labs, you can use this file and you can create a demo net. You also need a subnet for your network. So again, Neutron subnet create demo net, name demo subnet gateway. Then you will need to create a virtual router for the routing traffic. Neutron router create demo router, and now connect the router with the tenant subnet from the one side, that is Neutron router interface add demo router demo subnet. Okay, that's how you create that, creating the routers and then adding subnet to the router, right? So let's add our existing network to the router. So we'll create a router, that we will create a demo router. So let's create a demo router. Okay, so Neutron network router create demo router, and now we will add our own network to this demo router, right? We'll use this interface add demo router, and our own subnet will add to this. Okay, and our subnet is ext-net. Oh, we need to have a subnet, sorry, subnet. Added. Now you can see that it is added. You want to see it is a very beautiful way to see here. When you are working on this, you can click on this network topology, and this gives you a very beautiful way to manage the network here. Look at this network topology. That's a very beautiful way, graphical way of visualizing your network and the routers, everything. You'll be able to see all those things here. Look at this, these are the networks, right? We created ext-net, ext-net1, and then my network, right? And if you go to graph, you will see these networks, and these are the networks, and we have not connected any of them right now. We have just created the individual components. The moment we connect this through the router, you will see them connectivity, right? So these are components. You click on this, you will get the details. Okay, TSP instance, this is our instance which is right now shut off. We are not connected this, and this is our ext net 1, and this is our ext net, right? That is my network, sorry, and this is ext net. So these are the networks, and good point is here is you can use a command. Where is that? Launch instance topology. Yes, let's move on. So we have created a router, and we have added the interface from one side, virtual router and ports, and from the other side you will need set ext net as gateway for the router. So let's set this also, gateway router and ext net. We have added subnet, and we need to add the gateway now. Neutron router gateway set demo router ext net. Okay, and now you will see the effect of this on the request ID is correct. Bad router request, router already has a port associated with it. Okay, we already have it, fine. Project network router tab, let's go to the router tab and see that. Project network the router tab, we want to see the router tab. Project volume compute network security group. Here we don't see the security group. Where is the router? What am I missing? T network. Must be see that here somewhere, subnet. The router was created. We could see that. Edit network. Create subnet. Network topology. Here, this is what? This is instance name. Okay, I will see that also, no problem. From other side you need to set extnet as a gateway for the router. You can now create a virtual router in Horizon also, project network and router tab. But we have not seen this, what we have missed. Let's go back and try once more. Neutron net create demo net. Demo subnet. We also create a demo router, right? Let's see router list. If we try Neutron router list, okay, let's try Neutron router list. Show you that router, if it is created, it will show you that. Yeah, it is created. Demo router is created, right? Oh, it is not connected to any external network. Right. Okay. So let's create another one. Perfect. Do one thing. Let's create this demo net and demo net and subnet with gateway. Net create demo net, right? So here we go. So here we are going to create the same. We are going to use the same set of commands for creating this. Net create demo net. We'll set the same set of commands. And now we will create as demo subnet. We'll use all of them. So good. This is created. Subnet is also created, right, with the gateway. And now once this is created, we create a demo router 1. We'll use demo router 1 this time, no problem. So we create demo router 1. we are creating a new router. We'll see that, right? And we'll use the same one demo router one in our next command, that is interface add. Okay, let's take a look at this. Is also created, and now to demo router one we are adding this demo subnet. And once this is done, we'll move on to the next command, which is Neutron router gateway, and we need to set it to the external network using this command. Yes, network interface added, and now we'll use it to connect to the external gateway. So demo router 1 ext net, and if this is successful, we should be able to see the router on the Horizon dashboard also. This should be successful now. Yes, fantastic. Now we can see it on the dashboard. Click on graph and you see that networks, now we should be able to see that demo network is also there, and network topology, we should be able to see the router also now. Come on, where is the router visible? Networks, am I not able to see the router in the network details here? Demo network, let me see. Subnet, ports, network router interface. I can see the detail, but surprisingly I want to find out the information about the router. Is it available here? Network, do we say that under this? Sometime we get these details here. No, no. On this network, DHCP agent, port, subnet. We can see the details, but interestingly we are not able to see the network router here. Why? I want to see the detail. I have created 4 networks, right? We'll see the association. It will not go back, because I remember I noticed, and we have done it in the past. Let me see, entire network, no. ext network, no. Router gateway attached to, yes, it's connected, but then it is not showing me the detail, router information. We have all the details, fixed IP, bindings, IP address, you can see everything. Okay, we'll check that also, no issue at all. So we have done this. You can create a virtual router in Horizon going project, network and router tab. That's what we are going, and we are not getting the router tab. That is what I'm saying. Network, project, network, tab itself not coming. Let me refresh it. That may happen. Sometime it happens. Sometime. Let me just log out and log in, if that is the reason. Because if I have created router, that should be visible here, that is for sure. I have done it in the past also. Let me log in again. Because of cache or because of that, it might be, because I can see that under this network, under network topology, do we see that? No. No. Networks, we don't see that again. Okay, I'll come back and help you in troubleshooting. I'll figure out where it is gone. Okay, now to create a port, what you need is you need to create the port. You can check all the routers, all the you can check all the ports. Remember that it is connection between the subnet and VNIC or a virtual router. So for that you can use the command neutron port show or neutron port list, okay, to see the port. So to take a look at the ports, we can use neutron port list, and these are the ports which are already there. Fine. And if you want to see a given port, you can use neutron port show and the ID of the port. And this is, I was trying to figure out the router. This was given here, router, right? Network topology and networks and routers. And I got this earlier. Sometimes surprising, I'm not able to get it. Under this network topology, under that we have that network and routers. I will see why it is not working. I'll figure it out definitely. At this point, your interface within one tenant network can connect to each other, but none of the interfaces can reach out to the external network. You need to add floating IP from EXTNet to the virtual machine. The default quota for number of floating IP is 10, and this can be adjusted by anyone who has the admin capacity. Let's take floating IP. Let's create a floating IP address. So for that, what we need is Neutron floating IP create EXTNet, and it will create a floating IP address for our network. I'm still shocked, and as I'm not able to see that network topology and security groups. I'm seeing everything but not the router. Very surprising. Network under admin also I'm not able to see. Project, compute, volumes, network. Come on, where it has gone? Shall I try on the service? No, it is not there. Big surprise for me. Why it is not appearing? I can see that on the command line, but I'm not seeing it here. Okay, floating IP address is created, right? Take a moment to locate the ID of the floating IP address. So we got this ID, and now you need to add this to the our instance. So Nova list will give you the instance, and this IP, this is the floating IP address 10.0.2.105. okay, now right now it is shut off, so you can see the port list also. After locating the IP address, you can determine the port ID from that list, right? Now you can associate the floating IP with the port. For example, if the ID of the IP is this and ID of the port is this, then you can use the Neutron floating IP associated with this ID of the IP and ID of the port, and then it will associate. So if you check Nova list again, you will find the second external IP and the virtual machine properties. Nova list, you can find information related to the floating IP in the horizon by going to the project network topology floating IPs. Okay, and this is where manage floating IP associations with the selected port. You can do that from this also. Okay, let's take a look at on the Neutron if we get this. I'm still not convinced that I'm not able to get the details on this. Do we see the floating IPs, subnet, ports, and this one is one which we created, floating IP address, right? topology port, and this is the ID, network ID, and the subnet ID, right? And this is our floating IP address. This is floating IP, fixed IP, the floating IP also. Manage project security group. Security groups are firewall rules that can filter ingress and egress traffic for virtual machines. They are implemented with IP tables rules in the reference configuration. To create a security group, you can use OpenStack security group, create, group name, description, and then you can add rules to it. Let's create it, the security group also, and this is the going to be the security group, and this is I'm creating right now. OpenStack security group, create, group name, description. All right. We missed this because this hyphen description is not required. Description is sufficient. Come on, hyphen is required here and not there. Yes, sometimes these silly mistakes create problem. Yes, now it is created, and now we can add rules to this. Okay, OpenStack security group, we are going to add rule to it. So OpenStack security group rule, create, and the rule is that protocol TCP, destination port 80, range is 80, from 80 to 80, remote IP address is this. So this is the rule which we are adding to it. All right. Okay, and security group created, that we should see here now. Finally we have this security IBM security group, and this we just created right now, and we can go to manage rules and we can see the rules here, right? And this is what we specified here, port number 80, ingress. So you can create the rules like this. So this is how you manage the security groups. Then when you can supply this security group to instance at boot time also, like Nova, boot, flavor, tiny image, this image ID, security group, and the group name while creating an instance. And you can remove a security group with OpenStack security group, delete, group name. To list the rules, you would use the command OpenStack security group rule list and the name of the security group. And you can see that from the Horizon dashboard also, as I have just demonstrated these rules, creating and deleting, all options are there. You can see the add rule tab also. Managing quotas. The quota limits the number of available resources. The default number of resources allowed per tenant is defined in the main configuration file, etc neutron conf file, under quota section. As an example, quota network 10, quota subnet 10, quota ports. Alright, so you can check the quota, you can specify the quota in your configuration file. Same way, a track quota uses, quota router, quota flagship, floating IP addresses, quota security groups, and quota security group rule. So you can specify and manage the quota as per your need. Quota and regular users, Neutron quota show. You can see the existing quota. Neutron quota show will show the quota, the existing quota. So right now this is the default quota. As we have discussed in the previous session also, quotas are managed very easily by using update quota, like Neutron quota update, and the quota ID, and the tenant ID, and the quota number, right? So admin can do the same, but only for any project with the hyphen tenant ID option. If an admin needs to change the quota for a given project, for a particular project, then this command can be used, like Neutron quota update hyphen tenant ID, that is the instance ID, and floating IP address 7. The Neutron quota list command lists the tenant for which per tenant quota is enabled, right? So you can use Neutron quota list. Admin can manage quotas on per project basis on Horizon. This is the exactly same what I discussed in my previous session also. By going through identity project, modify quotas through drop down menu to the right of the project list name. A user can check the overall limits including Neutron quotas in Horizon by going to project compute and overview tab. Let's take a look at the project compute and overview tab also. Project compute and overview, and you will see the all the quotas here under overview, and this is what it is along with the quotas and everything, like instances 1 of 10. These are all quotas, compute quota, volume quota, right? And this is right now the instance being used, created on this machine. Verify operations of network service. As mentioned earlier, Neutron consists of several components. Its configuration files were shown at the beginning of this session. Neutron API service is bound to port number 9696. The log files for Neutron service is available under var log neutron server.log, and you can check the supported extension for Neutron with the command neutron ext list. Let's take a look at neutron ext list supported extensions. These are supported extensions. And you can check the state of running agents with the command neutron agent list. Alright, that's all for this session. Thank you very much. Share your feedback at ramansangwan@gmail.com for one-to-one training, and for any other requirement you can call me on this number, and this number is on WhatsApp also. Alright, thank you. Bye bye.